let's apply what we know about like dissolves like to cannabinoids and terpenes. Remember, cannabinoids have slight variations on kind of a similar structure, and that produces the difference between THC and CBD and THCA and THCV and THCBN and all of them. But they all have a pretty similar format and a similar number of carbons. And within these, remember, we do have some polar bonds. We have these carbon-oxygen bonds. There's 3 of them. And this is looking at THC, and a carbon-hydrogen bond. And so we have one thing that can do a hydrogen interaction. And we also have a couple points that have dipole moments. However, the vast majority of this molecule is nonpolar. And so we'll see this THC compound actually interact more as a nonpolar compound than it would a polar compound. It'll have better solubility in oils or fats than it will in water. Some of this compound will dissolve in water, but it'll just be a much smaller amount than what would dissolve in a fat or an oil. And this also tells us where this compound would be stored in our body too. It's going to be stored in our fats rather than something that would be only soluble in water, which we would then probably flush out of our system a lot faster. We would see a quicker removal of it. Let's look at a terpene. And I'm going to just use D-Limonene as an example since we've spent a lot of time thinking about it. But all terpenes are variations of different sizes off a similar theme. Almost all of them, or a majority of them, have only carbon-carbon and carbon-hydrogen bonds. And so when I look at this, I don't have any polar bonds and I don't have any hydrogen interactions possible because I don't have OH, NH, or FH bonds in it. So the only thing I have here is nonpolar bonds. So that means this is only going to be soluble in fats and oils. And while our THC molecule did have that OH that could do a hydrogen interaction with another molecule or with water, and it had a little bit of a few points that were polar, that would have a greater solubility in something like water than something like D-Limonene. D-Limonene is not going to mix at all. So our terpenes are even less soluble in water, and so we'll only be able to extract them if we're using something that is a nonpolar solvent as well.